Welcome back to Workshop Wasteland. Unfortunately for this week's video, I did not get a chance to machine any of the parts and pieces needed for the next step of assembly, so you're going to have to bear with me this week, and I'm going to do kind of a hodgepodge of shop-made tools and equipment that I've used and come to really like throughout my workshop. Like I said, it's kind of a hodgepodge. A little bit of this, a little bit of that, but I think you'll find it pretty interesting. If you want to see anything kind of more in depth, or want to see more about a particular piece of equipment, go down there in the comments down below and leave a comment, and I'll be sure to take care of that for you and make a longer video about each tool. So as I mentioned a long time ago in a previous video, I really like 3D printing. It's great for, if nothing else, prototyping. So this is going to become a fly cutter. I 3D printed a prototype of it to start with, just to see what I thought, how it was going to work, see if it was too big, too small. And this is just printed with like 2 walls. It's actually a really good 3D print, very good quality. And like I said, this was just kind of for prototyping purposes. I think it'll work well. I might make the shaft a little bit smaller on this, but that'll probably be an upcoming video all on its own, making a fly cutter that is not 3D printed. That's actually made out of metal. Another thing that I've made is an optical center punch. You can kind of see in the window, you can see the crosshairs. So what you would do is put this down and align it with a layout line or a center punch or whatever. Pull out the lens and then put a hardened center punch in there. Give it a whack with the hammer, and then you end up with a nicely aligned center punch to lay out to or drill with or whatever. I recessed an O-ring in there, helps prevent it from sliding around, and it's really hard to see, but there's a scribed line that makes crosshairs on the bottom. You can purchase these, but I had the materials to make one, so why make one why purchase one when you can just make it? I've talked about this in the past. This is Winky's Workshop here on YouTube. This is his parting blade holder to cut off parts in the lathe. Fantastic part. He changed up the design a little bit now in a more recent video. If I would make it over again, I would go with the more recent video, but either way, this thing works wonderfully. Very, very worth making. The next thing, this is just a simple little mandrel. Nothing too crazy about this, but I was able to make different caps. So this is a basically like a circular saw blade, I guess you could say, for in the lathe for cutting slots. And I made this cap, which has a deeper recess to clamp that in there. And then also this is a gear tooth cutter, and I made this mandrel to hold that as well. And then this is a slightly different cap, which will clamp that into place as well. So kind of a dual purpose mandrel. Nothing really to that. Didn't have any plans or anything, just kind of winged it as I went. Ended up working really, really well. So, again, why buy it when you can make it? Kind of continuing in the 3D printing realm, I dabbled around a little bit with like a no-spill oil cup that you drop a brush into. I printed 2 of these. I was going to give this to one of my friends, but they leak. I think maybe you have to increase the flow or something on your 3D printer to prevent this from leaking. So unfortunately this was kind of a bust, but I'll reattack that. I know you can purchase them and they're not that expensive, but I have a 3D printer, so why not just use it? This is a 3D printed parallel holder. They fit in there really nicely, as you can see. They came in a wooden case that was really big, took up a lot more space than what this tiny 3D print does. So I find that being super helpful. I just kind of threw this up here. This is a really crappy made boring bar. As you can see, I welded a piece of high-speed steel into some regular This is like a cut off piece of metal. But I threw this out here because I just wanted to highlight, it doesn't have to be a perfectly made tool to be functional for a quick job. So I just needed to bore deeply into one hole, and as you can see, I have kind of a left and a right. And like I said, it doesn't need to be beautiful and win an award to be functional, and that's what that was exactly. My next 3D printing adventure that I have is, I'm sure you're familiar with a rotary table. So this is a rotary table, spins around in a circle, normally has a hand wheel over here, but what I did is coupled a stepper motor to it, and then you have this enclosure which houses an Arduino and a stepper motor driver, so you can put in the number of divisions or the number of degrees that you want this to turn, and it does the calculations for the gear ratio and all of that. And what I used it for, I had it stood up like this, and then had a mandrel clamped in here, something similar to this, and then used these gear cutters in the mill to run through and cut gear teeth, and it worked out really, really well. I think I have a scrap gear. We'll kind of demonstrate what this is. Scrap because I was dialing everything in, but you get the idea, right? So you use these special gear cutting saws, and they cut the tooth of the gear. Like I said, this one's scrap. It didn't work out very well, but that's alright, kind of a live and learn. Moving on to, this is going to be a new project. This is called a spin indexer. It takes 5C collets in the end, and again has a handle to rotate it, but I'm going to make a belt drive and put a stepper motor on that, and then this is going to be a much more consolidated controller for that. And again, that's primarily going to be used for gear cutting. My Ford Boy on YouTube years ago did the same thing with one of these. So I'm a little bit loosely following his plans, but making it my own. And the Arduino sketch already exists. It'll be the same Arduino sketch as this. Just have to change some of the ratios in the sketch to make it work, because this is more of a one-to-one drive, where this rotary table has quite a gear reduction inside of here, and the gear reduction for that is going to be a lot different, but that's okay. That's just some easy math to figure out. Continuing on to the 3D printing trend. So this is a stepper motor connected to the X-axis of my milling machine, and up here I have a 3D printed enclosure for one of these cheap little stepper motor drivers. So what this does is gives me power crossfeed. As you can see over there, it's rotating the handle, and then I can go the other direction, or of course you can stop. And the cool part is you can adjust this basically infinite. I can turn this way down to 5, and that's practically no feed at all. That's going super duper slow. Or you can crank this thing way up and just make it absolutely fly. As you can see, that handle's really zinging now. 3D printed way covers, 3D printed R8 collet holder back there. As you're going to see a theme all the time, I really, really like 3D printing. It's really good for prototyping, and also it's a super cheap way to accomplish the same thing that you need to accomplish. Over here at the lathe, I think I've shown this before. This is a 3D printed part with magnets embedded in it, holding an indicator, and it's nice because you can just pick it up and throw it down. The only thing that would make this better is if you could flip it around and put it on the back side of the carriage. If you could put it back there, but unfortunately I can't. This is 3D printed, and this runs off of the lead screw for whenever you're cutting threads. It gives you the number for the engagement point. These things are really expensive on eBay to buy, like an actual South Bend replacement part, that would be used or whatever. So this was available for 3D printing. So far it's worked fantastic. If it ever breaks, you know, I got $3 worth of plastic in there and only a little bit of time, so that was definitely awesome. And then I recently showed this in a video. This is my, call it kind of a hard stop for the lathe. Let me pop this indicator out of here and show you kind of what that looks like. So this clamps onto the ways just like that. And then it's a micrometer, you know, like the guts out of a micrometer. So I'm able to spin this and adjust it, and then it crams into the carriage for a hard stop. And it's not something I use all the time, but whenever you need it, it's definitely nice to have. I use my dial indicator more often just because it's quicker and easier to set up, and it just kind of hangs out on here all the time. Just kind of lives there like that. So this green machine over here, as I like to call it, is a 2x72 belt grinder. What that means, a 2-inch wide by 72-inch long belt. As you can see up there, I have quite an assortment of all different kinds of belts hung up on the wall. I dabbled quite a bit with knife making, and made this whenever I was doing that. It can absolutely hog away some metal. I think you can get about 5,000 surface feet per minute, so this belt absolutely ripping down towards the ground. You can shower your feet in sparks. This was all a set of free plans. I don't know where they are anymore. I don't even know if you could find them, but this was all water jet cut out, and it involved some welding and some assembly. But you end up with this post right here. This supports what's called the platen. As you can see right here, this would be called a flat platen. And then down here you put a tool rest on, and then that's a tool rest that comes up against the belt, you know, to give you a flat plate. That's what this right here is. That's the flat plate that slides in. Inside of that blue cabinet is a variable frequency drive. I don't think you can really see, you can kind of see the display in there, but you have a knob to turn right here, turn the speed up and down to whatever you want, and then flip that switch back there to turn it on and off. And a variable frequency drive takes single phase in and gives you 3-phase coming out for this 1.5 horsepower 3-phase motor. So you have forward and reverse, and you know, basically an infinite speed from 0 to 5,000. Then because of math, that drive wheel is 4-inch, I believe, and that basically means whatever RPM the display shows is the surface feet per minute of the belt. It also has the ability, you can loosen up this knob and then lay this over, so now the belt is on a horizontal instead of vertical. So it's definitely a well-designed, well-thought-out belt grinder. I'm super, super glad that I made it when I did. This right here is another tool that can go in to use different size wheels. They pop in there with bearings. I think this one is 1/2 inch, and I think I can go up to 2-inch. I made these wheels a long time ago for the platen setup like that. So this thing gets used practically on every job. Does a wonderful job at sharpening lawnmower blades, things like that. Grinding or profiling a chisel, you know, you name it. Obviously it works well for knife making because that's what I did with it to start out. Over here is a Harbor Freight portaband. I made this table for it to hold it, so as you see, you know, so you can cut material in here like this. It's made out of an old treadmill frame, actually. My very first belt grinder was homemade with a treadmill, and then I kind of cut it up and repurposed it into this. You only have to take out a couple of screws, and you can take this saw out of this setup and, you know, be able to use it as it was intended, as a portaband. And then down here on the ground, as you can see right there, it's got a foot pedal that turns it on and off. In the event that you buy one of these foot pedals, they have 2 of them. This one is momentary, so you step on it and hold it down, and that makes it run, but whenever you let your foot off, it stops. The other one that they have is like a switch. You step on it and it stays on, and then you have to step on it again to turn it off. So make sure you don't get that one. Get the momentary on switch. I guess one last thing here. This is a ceramic kiln. Right now it's used for chemical storage, but I hooked up, right here is a PID controller. I hooked up a PID controller to this to control the temperature, and I use that for heat treating metal, which works out really, really well. It's just not something I do too much anymore since I'm not making knives, but I think I picked that thing up for like $25 off of Craigslist back in the day when Craigslist was actually used, and probably put $100 worth of electronic components into it and made a legit heat treating oven. So that worked out well, and I have it in the event that I need it for, if I have to grind or profile some special tool for the lathe or the mill or something, I'd be able to heat treat it and, make it as hard as it needs to be or as soft as it needs to be. Over here I have, this is kind of my makeshift video editing setup and where I watch a ton of YouTube. As you can see, I got a TV, that's an old Vizio TV, and a small cheap monitor. And then up at the top there is my PC. It's actually a pretty well built PC, but I don't game or anything, so it doesn't need to be anything too exotic. You can see some of the also useful things about 3D printing right there. Let me zoom in on that real quick. You can use your imagination on what that might be, but that's entirely 3D printed. And last but not least, I have a pretty sweet sticker collection going from lots of different things that I've purchased over the years, or whatever have you. This used to house beer, but I don't drink beer anymore. Now it's got some sweet tea and some tobacco in it. I think every shop needs to have a beer fridge, right? Even if it doesn't hold beer. So yeah, super quick walk around of my shop. Show a little bit more detail about some of the tools that I made. And I think the purpose of this video was to kind of highlight the fact that you should just do it, right? If you need something, make something. If you need to try it and see if it's going to work out, just try it and see if it's going to work out, right? At the end of the day, you have nothing to lose, but really, in my opinion, you only have things to gain. So hopefully you enjoyed that video. Like I said, if you're interested in seeing any more details about any of the tools or any of the things that I've shown throughout the shop, go down there in the comments, leave me a comment, and I'll be sure to respond and make you a video or at least give you some information about it. Hopefully you enjoyed this. If you did, don't forget to hit the like button. If you'd like to comment, that'd be helpful. And as always, don't forget to subscribe. So until the next time, have a great day.